Unit 4, Investigation 2, Lessons 1 and 2. We're starting off with the entry ticket together. We're going to be reviewing how to combine like terms. Remember, you always want to take the sign that's in front as well when you're combining these like terms. So I'm going to color code every term that has an x squared. I'm boxing, and I'm going to put a little squiggly under 4x because that's my only term with x. So negative 3 plus 10 is 7. So I'm going to have 7x squared plus 4x, and that's my simplified expression. Here, parentheses don't really matter because this is all separated by addition. So this is the same thing as rewriting. So I'm going to go from highest to lowest degree. So I'm going to square x to the third. There's no other terms like that, so I'm going to change colors to green. Now I'm going to circle all my x to the second terms, and I'm going to switch colors again and do a little squiggly under the constants, which are negative 8 and 4. So if I am rewriting this, x to the third, 12 plus 2 is 14, so I'm going to get 14x to the second, and then negative 8 plus 4 is negative 4, so I'm going to get minus 4. This next one, I have a negative that I have to distribute inside the parentheses. I'm going to get negative 5x to the second minus 4x to the third. Remember, I need this from highest to lowest degree, so I'm going to box these up, and I'm going to say, okay, I can reorder this. So I'm going to say, okay, negative 4x to the third minus 5x to the second. Here we have 4x times x. Well, this one, we know x times x is x to the second, so we're just going to be left with 4x to the second. Part 1 of our concept development, we're going to be looking at this rectangular prism. It asks us, okay, well, I want a polynomial expression for the area of each region, A, B, C. I've color-coded each region, so we're going to do yellow first, which is the A. We know we have our width right here, but we also have our height because that's my expression. So now I have to distribute because it wants a polynomial expression in standard form, not factored. So I'm going to distribute, and I'm going to get this. So I can combine these two terms, 3x squared plus 17x plus 10. Now moving on to B, which is the purple region. I have my length right here because it's going to be the same length as the bottom. And I also know I have my width, which is right here, 2x plus 1. And then if I distribute, I can combine 3x and 4x because they're like terms. Lastly, I need my C region, which is my light blue region. And I have my width, and I have my height. So I'm going to have, and if I distribute, I get, and I can combine these two together because they're like terms. Now it asks, well, write a polynomial of the total surface area. But because this is a rectangle prism, there's 2 of each of these surfaces. So I'm going to have 2 of A plus 2 of B plus 2 of C region. And this is going to equal my overall surface area. I'm going to say surface area is SA. So now, since I already have my polynomials, now I just have to distribute and make sure that I combine all my like terms for the whole entire surface area. So if I distribute, I get, and now I'm going to combine my like terms. Now it asks us for the volume. So we're going to be doing a different equation because we know that we were dealing with area, which is base times height. Then we were dealing with surface area, which is adding up all the areas of the surfaces, all 6 surfaces. Now we want the volume, which is length times width times height. We have our length, width, and height, so we can just multiply all of them together. Now this is when we have to be careful with our multiplication. So we got to do one at a time. So let's multiply these 2 first. We actually already did this calculation for region B, and we can just multiply by x plus 5 after. So we got to distribute each of these terms twice. I got to combine my like terms. If I simplify here, this will be my volume. All right, so part 2 of concept development, we have another rectangular prism they're not showing us, but they're giving us the equations for. They give us the volume, the length, and the width, and we know our volume is length times width times height, so we're missing this height value. This Trevor dude thinks that this height should be 5x minus 3, and we want to know if we disagree or agree. Width times height. So we can solve for the total surface area given what we already know. 3, which is revenue, cost, and profit. A lot of businesses use these equations to make sure, okay, well, when am I going to be making profit? How will I be losing money? What's the best option for me to maximize or minimize costs and demands, right? So here, when you're reading this blurb, there's a couple important things to pay attention to. One, they said a profit is found by taking the difference between the revenue and the cost. And then it also tells you that the revenue function is equal to the number of units sold times the price, which is determined by the d of x, the demand function, times multiplication. So looking at this tech company who's making hard drives, the demand function is d of x, which is right here. And then it says the cost is given by the c of x. So it asks, well, what is the function for the revenue generated by selling x hundreds units of the hard drive? Well, we already know that the units are already in hundreds of units, so we don't need to worry about changing this. We can just use x as our variable for this number. So we're going to say, okay, the revenue is equal to the number of units sold, which is x units, times the price per unit, which is determined by this d of x. So we're going to say x times -0. So if I just distribute this x in, I'm going to get the revenue is equal to this. And that's all you have to do. You just have to distribute that x in, because we don't know the actual number they're asking us to make this calculation for. So because we don't know the actual x value, we need to deal just with the x. And that's why you see these powers are the only thing that really changed. Now asks, well, how much revenue will be created by 1,000 hard drives sold? Well, now instead of x, they give us a number. So we're going to recalculate this using 1,000. And you actually don't need a calculator for this, because if you're multiplying by 1,000, you're going to go to the right 3 decimal places. And this is our revenue for selling 1,000 hard drives. Now it asks us for the profit. So to calculate profit, we know our P of X is equal to whatever our revenues are minus our cost of making those drives, right? Because we want the profit. We want to know demand minus the cost of making all of that stuff. And now we're going to see, well, whatever the remainder of that is my profit. Actually, we know our revenue. And again, it's for selling X hundred units. So we're looking at this polynomial, not from number 7. So we're going to say P of X is equal to the revenue minus the cost. You can just distribute this negative here, and this will give you negative 15x minus 100, but this stays the same. So now I need to combine my like terms. So if I rewrite this, I'm going to get -0, this as my profit. Now it asks us, okay, well, at what level of production will the company make a profit? Well, we need to graph it. It's a level of production the company should establish to maximize profit. These are all things that we've dealt with last couple weeks, when we were looking at polynomial graphs and what they tell us at each point. So I'm going to look over here. I'm actually going to look on, I don't really care about this left side of the polynomial, because there's no such thing as negative products, right? Because the X is standing for number of hard drives, so there's no negative number of that product, right? So we're going to start from 0 and go to the right towards positive infinity, asking us at what level will the company begin to make a profit. Here they're making negative profit, and it's not until they reach this root, which is 7.223 hundreds of hard drives. It's not until after that moment that they start increasing their profits, right? And then they reach this maximum where they kind of go back and decrease in profit again. All right, so level did the company begin to make profit after 7.223? And now it says, okay, well, what level of production should the company establish to maximize profit? Well, we know we have a maximum point here, so we should be producing 16.12 hundreds of hard drives. this is lesson 2 entry ticket. We're going to be doing this together. Little refresher on long division with integers. So they give you a step-by-step solution to solving 462 divided into 3. So we need to know what the divisor, dividend, and quotient is. Well, quotient is always going to be the answer, right? It's the answer to any division problem. That's what a quotient is. And your divisor is going to be what you're dividing your dividend into, right? So it makes sense that if you have 462 divided by 3, you're seeing how many times does 3 go into here, okay? So in this situation, 3 is our divisor and 1245 is our dividend, and we're trying to look for a quotient. So I'm going to set it up just like they did up here. And I'm going to say, okay, well, how many times does 3 go into 1? Well, 0 times. 0 times. So I still have 1 left over. I'm going to bring down this 2. I'm going to say, okay, well, how many times does 3 go into 12? Well, 4. And then I have 0 remainder. Next, I can bring down this 4. So how many times does 3 go into 4? 1 time. So I'm going to have 3 here. 4 minus 3 is 1. I'm going to bring down this 5. And I'm going to say, okay, well, how many times does 3 go into 15? Well, 5 times. So the answer to this question is 415. Using the same process, 3 goes into 1 0 times. So I'm not even going to bother with that step that I just took in the last problem because I know I'm going to put a 0 here, right? 3 times 4 gives me 12. So I'm going to put a 4 up here, and I'm going to have 0 remainder. Now I'm going to go to the 4. 3 goes into 4 once. I have 1 left over. I'm going to bring down this 4, and I'm going to say, okay, well, 3 goes into 14 4 times because 4 times 3 is 12. Subtracting 12, and I have a remainder of 2. And another way to write this is as a fraction. So I'm going to say, okay, 414 and 2/3. So your remainder is always going to be your numerator. Your divisor is always going to be your denominator. It's concept development for lesson 2. They give us a bunch of information, so I'm going to highlight the important parts. They give us the amount of money spent at the movie theaters, okay, and hundreds of millions of dollars. This is a lot of money that we spend on movies in the United States, okay? And so they give us this function m of t, so money m. So this is the polynomial that represents how much money we spend. And then it says the population of the U.S. is p of t, so p for population, in tens of millions. And then we have the price per capita, so average money spent per person on movie theaters, which is going to be calculated by taking the money spent at the movie theaters that year and divide it into the population of people in the country for that year. Okay? So in this situation, they're giving us our t values, right? And then we have to substitute in that t value to solve for our money spent, population, and then the cost per capita. So let's start by saying, okay, well, we have t is equal to 1, so I substitute in 1 in for t. So here I'm going to get, this is going to give me 32, and we have to solve for population. So again, we're substituting in 1 for t, and we get 27. And now we got to find the cost per capita, which is taken by the money spent that year in total, and divided it into the population that year in total, and we're going to get an answer of 1.185. I'm going to do one more example with you. So if we are substituting in 2, we're going to solve for it the same exact way. I get 27. Substituting in 2, we get 29. And again, we're going to calculate the cost by taking the money spent that year, 27, divide it into the population for that year, which is 29, and I get 0.931. So you're going to continue. I'm going to have you guys do these 3 on your own. Then it asks us if we want to divide the polynomial m of t by the linear function p of t, and would that be helpful in calculating the cost per capita? Well, kind of, yeah, right? Because you're taking the money spent on movies, you're calculating that first, then you're calculating the population separately, and then you're dividing them. So it would kind of help, but that would involve long division. So you'd have something like this, very similar to when we did 3 divided by 142. but now we're doing it with polynomials. But it doesn't ask us to do it just yet. It's just asking what is the unit of measure, and that's going to be price per person. But down here, this is where they do our calculation for us. So this equation we had up here, the money spent per year, right here, divided by the population that year. And they do that out for us right here with long division. And they tell us that here we have a remainder. Same rule of thumb goes when you have division with polynomials, right? The remainder is going to be the numerator and the denominator is going to be the divisor. So here they're having us calculate these separately. So this is the first part, and this is the second part right here. But notice here they have C of t is equal to this, and then they have to take the C of t and subtract this remainder. That's the same exact thing, because you're saying, okay, let's do this first and then subtract this. All right, so here we're going to do the same exact thing. Here we're going to do the same exact thing. We're going to substitute in 1 for t. Then it's asking us to take what we just solved for and subtract the remainder. And then I'm going to ask you to fill a table in the same exact way. And you're going to figure out, well, did this table give me the same? With the first one, 3x plus 4 is the divisor, and 27x to the third plus 0x to the second plus 0x plus 64 is a dividend. You're going to understand in a bit why the 0x squared and 0x are important. You just need those place values as holders. I'm going to start with the 27x to the third, and I'm going to say, okay, well, what can I multiply 3x by to get 27x to the third? Well, I know it's going to be something with x to the second, because x to the second times x gives me that x to the third. And I know that 3 times 9 is 27, so I'm probably going to be multiplying by 9x squared. So if I do that, 9x squared times 3x is 27x to the third, and 9x squared times 4 is 36x squared. Remember, you are subtracting this. So 27x to the third minus 27x to the third gives me nothing. Then I have 0x to the second minus a positive 36. X to the second, that's going to be negative. So I'm going to have a negative 36x to the second. I'm going to bring down this plus 0x. And now I'm working with this negative 36x to the second. So I need a negative number because 3x is positive. And I know I need something with x because x times x will give me that x squared. So I need something that's going to equal 36. 3 times 12 is 36. So I'm going to say minus 12x. If I multiply negative 12x times 3x, I get negative 36x squared. And then negative 12 times 4 is 48. Times that x is x. So here again, remember that you're subtracting these values. So they're going to become positive. So you get 0x squared and you get a positive 48x. Now I'm going to bring down the 64. And I'm going to say, okay, well, what times 3 can give me 48? 48 can be divided into 3. How many times? Let's do long division on the side. 3 goes into 4 once. I have 1 as a remainder. I bring down this 8. What times 3 gives me 18? 6. And I get no remainder. So let's do 16. So 16 times 3x is going to be 48x. 16 times 4. 6 times 4 is, and remember you're subtracting this. So then you get 0 remainder. Number 2, I know that to get a squared, I need something with an a. I know that 7 times 4 is 28. Okay, 4a. 4a times 7a is 28a squared. 4a times negative 2 is negative 8a. Remember, you're subtracting this. So then this becomes plus a negative, and this becomes plus a positive. So that's going to be 21a. I'm going to bring down this 6. Okay, well, 7 times 3 is 21. And 3 times negative 2 is negative 6. Subtracting both of these, you get 0 remainder. Last example, 2r to the second times r is going to give me that 2r to the third. 2r to the second times 5 is going to give me 10r to the second. Remember, you're subtracting. So this becomes plus a negative. These cancel. R squared minus 10r squared is negative 9r squared. I'm going to bring down this negative 46r. Negative 9r times r is going to give me this negative 9r squared. Negative 9r times 5 is negative 45r. Remember, you're subtracting. So this becomes plus a positive. These cancel, and you're left with negative r. I'm going to bring down the negative 5. And to get negative r, I'm going to multiply by negative 1. So negative 1 times r is negative r. Negative 1 times negative 5 is negative 5. Remember, you're subtracting this. So this becomes plus a positive. These both cancel, and you have no remainder. So your answer is 2r squared minus 9r minus 1.